Okay, so today we are going to begin with factoring polynomials. We're going to start out slow. We're going to first just look for a greatest common factor. So let's go ahead and look at the first slide. So on the first slide, it's talking about factoring out a GCF. Now, this GCF that I'm talking about, this is the same thing that you learned probably back in 4th grade, maybe even 3rd. Of finding a greatest common factor. When you did it back in elementary school, we didn't deal with variables. That came later on. So those wonderful times tables that you learned in 3rd grade, this is going to be really important for factoring and being able to find the two numbers that are going to multiply to give us the number we're looking for. So knowing your multiplication times tables is going to be really key here. So in this one, you should always look for a greatest common factor always before you start the problem. Now, in this particular problem, we're looking for the greatest common factor between first the number part, the 6, the 9, and the 18. So we can clearly see that it's going to be 3. Then we're going to look to see what letters or variables that they have in common. And notice the first one, the 6, has an x and a y. The middle term has an x and a y, but that last term only has the letter y. So the only letter that's in common is the letter y. And when you're looking for the greatest common factor, it has to be in common to all of them, so you're looking for the smallest exponent. So of my letter y in each of the 3 terms, it's going to be y to the 3rd power. So what I'm going to do there, and what I like to do is use this method down here where I show that I'm dividing each term by the greatest common factor, and then the answer to the division goes in the parentheses. When I did it here, I was just showing you that after I pull out that 3y cubed and multiply it by each of the terms, that's what I get. Okay, so we're going to try some examples of looking for a greatest common factor. Now, yes, I know that I left behind a little square there. What is going to be my greatest common factor between 9x to the 5th power and x squared? Up in the front.
X squared.
Beautiful. So that's what was there. So I'm going to put x squared there. And now I'm going to divide each of the terms. So what I like to do is, just so I can see and I don't forget anything, I'm dividing each term by x squared. So when I divide 9x to the 5th power by x squared, what's left behind?
X cubed.
Okay, so 9x cubed. Okay, and then when I divide this term by x squared, what's left? 1. Okay, it doesn't cancel away. Anything divided by itself is 1. Now remember, I can take what I just created and I can check that I did it correctly, and I can distribute or multiply out that GCF back to my binomial. So when I multiply it back, I end up with 9x to the 5th, and then I'll multiply here, and then I get x squared. If it doesn't go back to what you originally started with, you've done something wrong. All right, let's try the next one. What is going to be my greatest common factor? Let's just do the numbers first. Between 6, 8, and 12. Sean?
T.
Okay, they all have a letter T. What number would be a greatest common factor? What else can I include? I'm sorry? 3T?
Oh wait, sorry, 2T.
Beautiful, 2T. Okay? Now, again, I'm showing what I'm dividing each one by, so I have a visual. You don't have to show this. You could jump right to the answer, and then you're going to write the greatest common factor outside of the parentheses, and in the parentheses will be what you get, or the result of the division. So 6 divided by 2 is 3, and then when I divide, nothing to divide by the x, so I'm going to put the x squared back, and the t's are going to cancel away. Then 8 divided by 2 is 4, and then it still has an x, and then 12 divided by 2 is 6. And I'm finished. Now, if this resulting trinomial could be factored, I would continue factoring. Okay, however, this one is going to be prime. I can't factor it, so I'm finished. So right now at the beginning, all we're doing is factoring out a greatest common factor. Tomorrow, we'll factor out a greatest common factor, and then we're going to keep on factoring. So we're going to be factoring multiple times. This skill of factoring is not going to go away. Okay, you are going to be using factoring again in pre-calculus, in calculus, and any other math course that maybe you'll take in college. Now, if for some reason you decide to go a different route, and let's say you take college algebra or advanced topics, you will factor in those classes also. So no matter what path you take from this course, you're still going to factor. Factoring does not go away. Let's try the next example. Now, sometimes your greatest common factor is going to be a negative number. Now, in this case, notice that both of my terms are negative. So when I pull out my greatest common factor here, all right, so what is going to be my greatest common factor for number 3? And you can give me numbers and letters. Okay?
Negative 3, z to the power 2, and w to the power 2.
Beautiful. Everybody see that? They both have the letters z and w. And again, you're looking for the smallest exponent on each of the letters. So z squared, w squared. And now I'm going to divide it. So I'm going to write the greatest common factor on the outside of the parentheses. And inside the parentheses are going to be the result of my division. So negative 3 divided by negative 3 is 1. I don't need to write the 1. And then when you divide exponents, we're going to subtract them. So z to the 5th minus z squared, or divided by, I subtract them, and I'm going to get z to the, let's see, z to the 3rd power. And then for the w, it cancels away because 2 minus 2 is 0. Anything to the 0 power is 1. And now I'm going to divide negative 18 by negative 3, and I get 6. And then the z's are going to cancel because 2 minus 2 is 0. 4 minus 2 will give me w squared. And that's your factored answer. Number 4. What's going to be my greatest common factor here?
7r to the 3rd power s.
Okay, 7r to the 3rd power s. Again, I'm going to divide each one of the terms by that 7r to the 3rd s. And again, if you don't want to write the division underneath, all I need to see is the greatest common factor on the outside of the parentheses, and then the result of dividing each one of those terms by that GCF. So once I divide 28 by 7, I get 4. I subtract the exponents. 4 minus 3 on the r's gives me r to the 1st. And then s squared minus s to the 1st is just s. And then here it's identical, so I need to show that it's plus 1. And then the last term, negative 35 divided by 7 is 5. I'm going to subtract the r exponents and subtract the s exponents. That's the final answer there. Pretty good on that? All right, number 5. Okay, for this one, it's a little tricky, and you might look at it and think, wait a minute, I got to distribute. But what it's asking you to do is factor this. What's going to be my greatest common factor here?
Y minus 2.
Beautiful. okay? It can actually be a binomial. So my greatest common factor here is y minus 2, because they both have a y minus 2. So I'm going to show the greatest common factor out here. And now I have to divide each of the terms. I still have the 4 there. Remains as a y minus 2. And then here is just plus 3. Now I need to simplify this, so I need to distribute. I'm going to distribute the 4 to the y, 4 to the 2. This is going to leave me with 4y minus 8 plus 3. I now can group these like terms. So y minus 2 and then 4y minus 5. And I'm finished. Another way to do this is you could give y minus 2 a variable and factor it that way. So another technique to do this one is when your greatest common factor is a binomial, you could start out by saying, I'm going to let u equal y minus 2. And then I'll rewrite the problem as 4u squared, because I've taken out the y minus 2, and then I can factor it this way. It works this way also. Then my greatest common factor here is the letter u, and then I'll do u, and then I'm left with 4u plus 3. And then at this point, I plug everything back in. So then at this point, you can use either method. So now I'm going back to what I set u to be equal to. So I'm going to do y minus 2, plug in here, y minus 2 back for u, substitute. And now I'm going to distribute 4y minus 8 plus 3. And then essentially I'm doing exactly the same thing that I did over here. So y minus 2, again group the 8, negative 8, and 3. And I get exactly the same answer that I got over there. Either method is acceptable. Okay, let's try number 6. What's going to be my greatest common factor on this one? Mackenzie.
Negative 8x to the power of 3 and y.
Okay, negative 8x to the third power y. Beautiful. Okay, again, I need to divide. So I'm going to write my GCF on the outside of the parentheses. And now I'm going to complete the division, and that's what goes in the parentheses. So negative 16 divided by negative 8 is positive 2. Notice the variables are exactly the same thing. So anytime I divide anything by itself, it's just 1. So I leave the 2. And then here, negative 24 divided by negative 8 is positive 3. X to the 4th divided by x to the 3rd is just x. And then y squared. And I'm done. Good? Next technique we're going to talk about is factor by grouping. So when you have a polynomial that has more than 3 terms, it can sometimes be factored using factor by grouping. So for example, I've got 4 terms here in this question, and I'm going to try to group them so that the term in there's at least a common term in each group. So notice in this first group here, the common factor is the letter A. In my second group here, my common factor is going to be 6. And then I factor each one independently. And then after I do that, I pulled out the letter A, divided. Here I pulled out the number 6, divided. Then what I do is now I have another common factor, which now is going to be x plus y. I write it here. And then I group the 2 GCFs that I pulled out in my other binomial. So we're factoring out an x plus y. So here's another example. Now, you can also rearrange the order of the terms. You don't need to leave it in exactly the same order. Sometimes it doesn't matter. You can do it the way it's there. Sometimes you're gonna have to rearrange them and apply the commutative property. So in this one, my common factor I can see is the letter m. So I'm dividing both of the terms by m, and then the result is the p squared plus 7. Over here, my common factor is gonna be the number 3. Divide. Now, when you're factoring by grouping, your goal is to get another common factor. So once I do the division, this parenthesis needs to be the same as this one, because that now becomes my new common factor in my final answer. So if you are factoring by grouping, and the parentheses on this line, right in here, if this does not turn into the same thing, you can't factor by grouping. Let's try the next example. All right, I'm going to rewrite my problem here and add in my parentheses. I'm going to leave it in the same order. So I'm going to write 10a, b, minus 6b, put it in a parentheses. And then I'm going to write the 35a minus 21. What is going to be the greatest common factor of my first set of parentheses? What number and what letter is in common?
2b.
2b. And then I'm going to divide it. So if I want to just show that I'm dividing by 2b here. So then 10 divided by 2 is 5. And then the a is left behind, minus 3. What's my greatest common factor from my second parentheses?
7.
Beautiful. So then I'm going to show that I'm going to divide both of the terms by 7. And again, notice what I just wrote in red here is exactly the same. When you factor by grouping, again, you're trying to make another common factor. Once you get the same thing, you're going to write it over here, 5a minus 3. And then you're going to write in the second parentheses the 2 GCFs that you pulled out. And you're finished. This is called factor by grouping. All right, 3 more examples, and we're finished today. Let's go ahead and try this one. All right, for this one, do I want to keep it, if I keep it in the same order, do I have a GCF of those 2 terms? No. I need to rearrange it. So I'm going to rewrite it. So I'm going to put my 2y squared first. Which term should I group it with? Okay, the ay squared, right? So I'm going to take that last one and I'm going to move it up here and put it in the parenthesis there. And then I'll just take the next 2 terms, the az and the 2z, and put those together. Be careful when we're working with letters or variables other than x, especially when we're working with a z or an s. Make sure you're writing neatly so you can read your own writing, and don't think that that letter z is a 2. So be careful. And sometimes s's turn into 5s. So make sure you're writing neatly. All right, now that I've made my 2 groups, what is going to be my greatest common factor of the first parentheses?
Y squared.
Beautiful. So I'm going to divide each one of these by y squared. So I'll write the greatest common factor outside. I'm going to perform the division. 2 will be left, and then the letter a. What's going to be my greatest common factor of my second set of parentheses?
Z.
The letter z. Beautiful. So I'm going to divide each of these by z. and then I'm left with an A. Now, okay, let's watch this. So when I divide this, notice I've gotten 2 minus A and A minus 2. What do I need to make sure happens? Can I leave it like that?
That would be divided by -1.
Okay, good. So now at this point, you can either do another factor of a -1 out, or you could have just factored out a -z. Okay, because again, remember, when we're factoring by grouping, these two parentheses need to look identical. They can't have opposite signs. So in order to make them look the same, I can factor out a negative GCF. So at this point, I can either divide this one by -1 to make it the same, or I could have initially just factored out a -z, and then it'll save a step. So if I divide this by -z, then this turns into -a and +2. And then I can flip it around, and then it looks the same. So then I can make it 2 minus A, and then it looks identical to this one. Okay, now I need to take the next step. I now have the greatest common factor, which is going to be 2 minus A, and then the 2 GCFs that I pulled out. Now, remember, one way to check this is you can take your final answer and you can FOIL this, and it needs to go back to the beginning. If it doesn't, you've done something wrong. So remember, whenever you're factoring, you can always multiply your answer that you have, and it should go back to the original problem. Let's try the next one. Are we going to rearrange my terms? I'm going to leave them the same, right? It'll work there. All right, so let's go ahead and let's rewrite it. 4x to the third plus 2x squared minus 2x minus 1. Okay, so I'm going to group these here as they are, because you can pull out a greatest common factor that's 1 or -1. So for the first one, what is going to be my greatest common factor of the first parentheses? Danielle?
2x squared.
Okay, beautiful. So I'm going to divide each one of the terms by 2x squared. After I divide that, what remains is 2x plus 1. Now again, remember, I'm trying to make this parenthesis and then the one I get after I divide the same. Right now, look what I got. How can I make this turn into this? What can I divide out?
-1.
Beautiful. So my greatest common factor here is going to be -1. So I'm going to divide the whole term, both of them, by -1, and now it'll look the same. So now I'll take my greatest common factor, or my common factor, which is 2x plus 1, and then I take the 2 GCFs that I pulled out, and I'm finished. We can leave it, or we can put the 2 m's together and then the 15 and the 3 r squared. Either way, we'll still be able to get a GCF out of that. All right, I'm going to work it as is. So I'm just going to put parentheses around the 15 and the -5m squared. And then here I'm going to put it around the -3r squared plus m squared r squared. All right, what's going to be my greatest common factor of my first parentheses? Up front.
5.
Beautiful. Divide everything by 5, and I get 5. And then here I'm going to get 3 minus m squared. Over here, what's my greatest common factor going to be?
R squared.
Okay. Now, all right, let's try just plain old r squared. Let's see what we get. If I divide by r squared.
Oh, I actually did -r squared.
Beautiful. Okay, we're going to pull out a -r squared, so that way the two parentheses, or our two common factors, are going to be the same. So a -3 times a -r squared will give me +3, And then over here, this will become negative m squared. So now I do have a common factor. My common factor is 3 minus m squared. And then I put together the two greatest common factors. I'm done.